Hello, welcome to Fun Python Projects. In this video, we'll be looking at how to design a dice roller simulator, how to code a dice roller simulator, if you may say. All right. So, talking about a dice roller, right? We use dice in many games. Like, of course, there's this popular one in Nigeria called Ludo. And there's Snake and Ladder. There is all kinds of games where we use dice. So this simple dice roller simulator in Python has a wide range of practical and educational applications. It can be used in tabletop role-playing games like Dungeons and Dragons. Of course, I talked about snakes and ladders and all that to replace or supplement physical die, ensuring fair and reproducible results. So, if you use this kind of die on the computer, you can be sure that there's no unfairness, there's no bias. In education, can serve as a hands-on tool to teach concepts of probability, randomness, and statistics, allowing students to simulate and analyze outcomes of different dice combinations, right? So maybe sometimes you just want to talk about the sum. Maybe you're rolling two dice, and you want to take the sum on the two dice, or you want to take the products, or you want to try the die a couple of times and take the average and all of that. Okay. So developers and data scientists can also adapt it for Monte Carlo simulations, random sampling, or game prototyping, where repeated trials and probability distributions play a central role. So beyond gaming and learning, it provides a foundation for building interactive apps, GUIs, or Jupyter-based simulations that explore randomness in decision making, risk analysis, or even cryptographic demonstrations. So let's look at the Python implementation of this dice roller simulator. Of course, here we import random because we need to generate random numbers. You want to roll the die and get random values from the face of the die. Then we import this RE, which helps us to pass. For passing, as you can see, its application in line 6 here. So to compile all the possible ways in which the die can come out, like the numbers on the face of the die. Then we import statistics to get things like average, mean, and things like and other thing, minimum, maximum, and all that from the dice, right? So in line 5, we have a comment rejects to pass NDM plus X format. So this is more like one of the places where the key job is being done. So you have the pattern of the dice. Okay, so you have re.compile. So this re that you imported in line 2 now, dot compile. Then you have r. So this in bracket slash d star d into slash d plus minus. So this helps us with the pattern format. And then we define a function called roll dice. Okay. So, and you have an expression string times, that's the number of times the dice should be rolled. And it's integer. And then we have a default value for that, which is one. So if you forget to type the number of times you should roll, to automatically roll at least once, right? So at least for any game, most of the times you roll it just once. But maybe for some other situations, you may need to roll it more than once. So roll dice with an expression like D6. D6 is you rolling a die once with a die that has six faces. You are rolling it once. Then 2d8 plus 1 means you are rolling a die with 8 faces twice, or you are rolling two dice that with 8 faces, and then you're adding one to the sum of the results you get, and so on and so forth. So if you have D4, that's a die with 4 faces, D7, a die with 7 faces, and so on. And that is made possible by the pattern that has been taken care of right here. So, of course, this times size number of repetitions, like I said earlier, and it returns a list of dicts with rows and totals, like that. So now the match, to play the match, you have pattern. So from this pattern now, dot full match, and then you take the strip, the expression, be it D6 or 2D8 or whatever you're working with. Then if not match, then it will raise a value error. So if you have a valid expression, an invalid expression, so it says invalid dice expression. So you need to use something like D6, 2D8 plus 1, and things like that. D4, 2D4, 3D4, and all of that. And then we talk about the counts because we need to do some statistics, right? So counts. So that will be integer now. Match group one. If match dot group one, else one, sites. So how many times are you playing? That's the count. Then the sites. How many sites does it have? And all that. Then you have the modifier. So integer match group three. If match dot group three, else zero. And then you have so you compile the results. All right. So this is like an initial value for the result. Empty some place where the result is updated. And that's where, so for everything in the range, the number of times you roll the dice, so the rolls will be random dot randint one, one, they're talking about the number of sites for everything in the range in the count. Then the total is sum of rolls plus modifier. So, and then you have result dot append. So the rows, the modifier, and the total will be appended to result here. And then you return the results, having done everything you need to do. But then the next thing you want to do is this print results now. So you also want to print results. So for print result now, so of course you have this line. You want it to come out 40 times. So result for whatever expression, maybe for D6 or whatever. And then for I and R in enumerate results, comma one. So you have row string plus, then you join that talking about the number of rows, then the modifier string. So you have R modifier plus modifier else, print row, row string and all of these things. And then you also print. So this is like a kind of ruling to give a kind of beautiful formatting. And then of course you can then do the statistics. So you need a summary, the minimum of the rows if you have more than one, the maximum. If you have one, everything will be the same. The minimum will be the maximum and the minimum mean two. If it's only one, but once it's two, you can get the smaller, the bigger, and the average, basically. So for starters, we run this. So this is just uh the the foundation because this won't give any results. So it's done now. So you can see it's not giving any results. But based on this, now we can begin to play the game. So the foundation is set with this done. Okay. So now let's say, imagine you want to roll a one side, you want to roll one six-sided die. Okay. So roll D6 once. Okay. That's rolling one six-sided die. So six-sided die is D6. And the fact that you don't have any number in front of this D means you're rolling it only once, right? So if you put two here, it means you are rolling two six-sided dice. Okay. So here, we want to roll one six-sided die, and we have a variable name result, which is roll underscore dice, that D6, and then you print the result of that D6. So you're just rolling it once. So if I enter this now, so that one roll gives two. So it means the minimum is two, the maximum is two, the min is two also because it's only one result. If I roll it again, it still gives two. If I roll it again now, it gives one. If I roll it again, it gives one again. So five, six, four, five, and it just keeps going like that. Okay. So because you are rolling it once, but let's see this. You want to roll two six-sided dice, and you want to do that 10 times, right? So in this case, now it means you're rolling 2d6, repeat 10 times, and show the table, right? So here, the result now is roll underscore dice. All right. Roll just like what we have here. Roll underscore dice 2d6. That is, we are rolling two six-sided dice 10 times because that's why times is equal to 10. So if you do that, of course, see what you get. So roll one, the first die gives six, the second gives four. The first roll two, the first gives six, the second gives six, and their sum is 10. So you see, we are summing up, right? And then the last roll, the first die gives six, and the second gives four. If you add it up, you get 10. So by the time you do all of this, now you discover the minimum you get on any roll. I mean, the minimum sum on any roll is two. The maximum is 12, as you see on the second row, and the average of all the rows is you add up everything and divide by 10. That's 7.80. That's you rolling two six-sided dice 10 times. Okay, how about if you roll two eight-sided dice and then add one to the result, and you do that 5 times. So roll two eight-sided dice 5 times and add, I mean, each time you roll, you add one. And in that case, it means you are rolling 2d8 plus one, repeat 5 times and show the table. So the result here, roll dice, 2d8 plus one. That's the string now. So that string we saw the other time in the coding up here. This yeah, this expression string now, that's what takes care of that. So roll two eight-sided dice, add one, and repeat 5 times. So here, that's roll dice 2d8 plus one times equals 5, and then print the result. So if you do this, oh, by the way, I mean, for this, each time you run it, it gives a different result. So as you can see, each time you run it, it gives a different result. So the same applies to this too. So for the first time, since you are doing it 5 times, so it gives this first row 3, 3, last row 2, 1, and then adding 1 to it now, we get 7, 10, 14, 6, and 4. And then we have minimum is 4, maximum is 14, and then the mean is 8.20, like that. So if you run it again, you get this. So what if you want to increase this to maybe you can even make it this 50, right? That's a lot, right? So you can see how powerful this is, especially if you want to use it for some special something. So that can help. So you can go as many as you want. So it's really good for all these things like Monte Carlo simulation. So each time you run it, you keep getting different results like this. So what if you want to roll a 10-sided die 15 times? So just one 10-sided die, you want to roll it 15 times. I think one die is singular, DIE, not dice. Roll two eight-sided dice. That's plural. Roll two six-sided dice. Yes. Roll one-sided die. Okay, yeah, that's correct. Okay. So here, we are rolling a 10-sided die 15 times. Okay. So, and when you roll it 15 times, you can get the statistics, the average, the minimum, the maximum. So if you roll it 15 times, you know, um, now one issue is, do we get all the numbers? 1, 2, 3, 4, 5, 6. Interestingly, no 7. We have 8 and 10. So there's no guarantee that when you roll a 10-sided die 15 times, you get all the possible numbers. So you have some numbers showing up on this, like if you do the mode, for instance, you get things like 2. 2 seems to be the mode here. So we have this. So each time you run it, you get something else. You get another result. And you can extend this, you can do a 20-sided die, you can do whatever, you can do it as many times as you want and all that. So I think this is really useful. Like if you are teaching probability, this is a very useful thing to generate numbers like that. And then to play your games, if you don't have physical dice, you can use this as that. Okay. All right. So with that done, I come to the end of this interesting video about uh fun Python projects and talking about dice ruler simulator. Let me know how helpful this is for you. And if there's something you like on the tryout, feel very free to let me know. Okay. And if you have subscribed already to this channel, I say thank you so much. If you haven't subscribed, of course, you know you'll be missing a lot. Why not just go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you want to take it a step further by becoming a member of the channel. All you need to do is click on join, and you see 3 levels of membership, and that gives you some special privileges. Okay. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.